This video is on the objective understand the relationship between scatter plots and tables and determine patterns, after you have established this relationship. So what you're going to be doing here is you're going to be given a table of data in which the values of two variables, one independent variable and one dependent variable, are given, say an x and a y. And you're going to think of those as points on the coordinate plane, right, the xy plane, and plot those points. And that'll form what's called a scatter plot of the data. And then you're going to look at this scatter plot and see if you can determine a pattern. Do the points on the plot seem to be close to forming a straight line? Are they rising as you move to the right? Are they falling as you move to the right? Are they flat? Stuff like that. So this first question, again, almost every video I say this. If you want to see more about this, click on More Instruction. In fact, though, I do have a little bit about that for you. So, and then look at their videos, their notes and their examples. I'm going to go over some of their notes here. So on scatter plots. So a scatter plot is an easy way to display the relation between two numerical variables, say x and y, height and weight, age and IQ or something, I don't know. Right, any two numerical variables. And they are used often when discussing linear regression and correlation. Now I brought this up in a previous objective. There was an objective, a video earlier on the properties of linear equations. Linear regression is we're going to be looking at these scatter plots, a bunch of points of data, and we're going to try to figure out what is the best line for that data. Now the points might not fall in a line, but we're going to figure out like the line that gets closest to hitting all the points, without actually hitting them all. That's linear regression. The following example illustrates a scatter plot. All right. So again, I'm not going to read the example, just look at what we're doing here. Say X represents the year, Y represents numbers of users in millions, and you see it's like four ordered pairs here. X is 2,000, Y is a half a million. X is 2002, Y is 20 million, 20. Right? 2003, 33, 2004, 47. And you see there are four ordered pairs here. So I make a coordinate plane. And you have a horizontal axis representing the years, the X, and a vertical axis representing the number of users, or the Y, in millions. You see 2000.5, there's that point. Then 2002, and then Y is 20. There's that point. 2003, 33, there's that point. And then 2004, 47, there's that point. And this is called a scatter plot. It's, again, very simple. Just plotting points, taking tables of pairs of data and plotting those ordered pairs like you would in an algebra class. Now they go over here in this thing here, showing you how to do this on your TI 83, 84. I will show you that when we get to the question later. All right, so if you want to pause it now and read over this, go ahead, but I'll also show you when I get to the question that I'm looking at later. All right, so again, a scatter plot, a type of graph that displays the relationship between two numerical variables, x and y. And then they give me another example here. Again, pairs of data, plotting those pairs, right? And, well, one of these is the correct one, but yeah, in the explanation. Okay, and then we're going to be looking for patterns in scatter plots. So a scatter plot can show patterns in the relationship between the independent and dependent variables. A clear pattern happens when there is either, so high values of one variable occurring when high values of the other variable. Low values of one variable occurring with low values of the other variable. Or high values of one variable occurring with low values of the other. Right. So you can judge the strength of the relationship by looking at the scatter plot and seeing how close the points are to a certain type of function. Do the points look close to a linear function, a line? Do they look close to forming a parabola, a quadratic, or some cubic function, quartic, some power function, or an exponential? Does it look like an exponential curve, etc.? When you look at a scatter plot, you want to notice the overall pattern and any deviations from the pattern. Right? Deviations are just a little bit off, little errors. So the following scatter plot examples illustrate these concepts. So you see this scatter plot here. If I was looking at a scatter plot like this, you see how low values of x correspond with low values of y, high values of x correspond with high values of y for these points. If that's the case, do you see how the points are going from like the lower left to upper right here? And the points are very, very close. They're not exactly, but they're very, very close to forming a straight line with a positive slope. So they would say that this has a positive linear pattern, and it's pretty strong, right? Because again, these points are pretty close to forming a straight line. There are just a few deviations, right? A few points that are that make it not a straight line. Here, this is also that same linear pattern with one big deviation, right? This one point up here. But still, I would say that the scatter plot has a positive linear pattern. You have this one outlier over here, one deviation. Here are some points that have a strong negative linear pattern, right? They're close to forming. They're close again, close to forming a line with a negative slope, where you see that low values of x correspond to high values of y, and high values of x correspond to lower values of y. That's a negative relationship. Now this one, again, low x to high y, high x to low y, these points. So the points are tending downward as you move to the right. So there is a negative relationship. Right? There is a negative relationship. And you could say it's linear, but it's very weak. Right? These points are pretty far away from forming a line. Right? They're not like these points. These points are pretty close to forming a line. So I'd still say the relationship was negative. And if you want to say it's a negative linear, it's just a weaker version of a negative linear relationship. Now here, with these points, you see this definitely looks like one of those exponential functions, y equals 2 to the x, 3 to the x power, stuff like that. So this would have a strong exponential pattern. And then something like this, where the points seem all over the place, for low values of x, you got some points with low values of y and some points with high values of y. For high values of x, you got some points with low values of y and some points with high values of y. They're all over the place. They seem to be popped around here at random. So I'd say there's no pattern to this one, right? It's a very, very weak relationship between x and y. So this is what we're going to be looking out for. And for the most part, we're going to be focusing on linear relationships, do the data, do the pairs, do the value, do these variables have a positive linear relationship, and is it strong or weak? Do they have a negative linear relationship, and is it strong or weak? All right, that's mostly what we're going to be focusing on. Again, if you notice some obvious other pattern, you can state that as well. But so when discussing linear regression, we are interested in scatter plots that show a linear pattern. Linear patterns are quite common. The linear relationship is strong if the points are close to a straight line. There is a unique exception in the case of a horizontal line, right, where there is no relationship. Right? So horizontal lines, really there's nothing major going on between the variables. But we're looking for mostly positive relationships, negative relationships, positive sloped lines, and negative sloped lines. If we think that the points show a linear relationship, we can calculate a line on the scatter plot through a process called linear regression. All right, and we'll get into this in more videos in the future. All right, so they give you some examples down here. Now look, starts off low, and then as you move to the right, they get higher. So there is a positive relationship here, it looks like in general. And again, we're just going to say, hey, looks like lower left, upper right, positive linear relationship. Obviously with deviations, right? It's not, these points are definitely not forming a perfectly straight line. There are definitely points off of that line, definitely deviations. But this is what we're going to be looking out for. Right? It's weaker, right? They mentioned it's weaker, but it's still positive and linear, right? Because the points are tending upward as you move to the right. Right? And if the points are tending downward as you move to the right, then you'd say it has a negative linear relationship. And then how strong or weak that is, depends on how many deviations there are, how jumbled the points look. Okay. All right, so hopefully that made sense. All right, so what we're doing here, and I'll show you how to make these scatter plots on your calculator as well. All right. So here, a researcher explored the relationship between the percent of snow days during the month of January and the percent of students that receive an A on class finals at the same schools. The researcher collects information from 6 schools, shown in the table below. All right. Now this school number is just telling you how many ordered pairs there are. Really? Because remember, the researcher is exploring the relationship between the percent of snow days during the month and the percent of students receiving an A. So the X and Y here are these two columns. Right? The percent of snow days we'll call X maybe. Right? I think they do down here. Yeah, see, percent of snow days is on the horizontal axis. And the percent of students getting an A on finals, we'll call that Y. All right, and again, that'll be represented here by the vertical axis. And then the school number is really unimportant. It just basically tells you how many ordered pairs we're going to be plotting in our scatter plot. All right, so use the graph below to plot the points and develop a linear relationship between the percent of January snow days and the percent of A final exams. All right, so you're going to have to do this here. But first, like I said, I want to show you how to do this on your calculator. And it's going to be involving entering lists. All right, so I'll pull the calculator up. And you remember how to make lists of data, right? I hit the Stat button, hit Enter on Edit, and then say down list L1, or whatever empty list you wish. I'm going to put down these the percentage of snow days for these 6 schools. These will be my X coordinates, right? So I put the X coordinates down one list. So I've got 5 and 7, 10, 12, 20, and 25. All right, then down list L2, or again, some other empty list that you find. I'm going to put these percentage of A finals, right? Percentage of students who got A on their finals in these schools. So the Y, I'll call them again the Y coordinates, right? So I'll put the X coordinates down one list, the Y coordinates down the other, and make sure they're lined up, right? They got to be, these are both related. These are dependent variables here, right? They're both related to school 1, so I can't move the 25 to the 7 all of a sudden, all right? So the 25 here has got to be with this 5 here, and the 45's got to be with the 7. So just make sure you're putting them in the same order, right? 25, 45, 50, 65, 70, and 86. All right. So now that I have my X coordinates in one list, my Y coordinates in another list, let me get out of here. I'll go quit. And then remember how we make, it's been a while, but how we make most statistical graphs on your calculator. Above the Y equals button, it says stat plot. I go there, hit the second button, then hit Y equals for stat plot. And I'll go to just plot 1 here, hit enter, turn it on. Right. And then when you scroll down to type, the very first type with all these dots in it, this is a scatter plot. So I'll just leave it there. And what's your list of X coordinates? Well, that was already L1. Put in whatever list you need to. And then what was your Y list? That was L2. And again, if you want to enter different lists, they're above the number buttons here. Just hit second and 3 if you want L3, or second, then 4 if you want L4. And then this mark thing, just like, this is unimportant. It's just how do you want the points to look? Do you want them to be little boxes or little plus signs or little dots? I'll just keep little boxes. All right. Now I'm going to go to zoom. Hit zoom. And then there was that zoom stat. Right. If you scroll down, number 9 says zoom stat. You can just hit the number 9 as well. And what this does is it changes your window, changes the window on the graphing screen, so that all your statistical plots will show up on the screen. So I hit enter there, and there you go. Here is our scatter plot. Now you can see what the window was changed to, right? The lowest, it's going from an X coordinate of 3 to X equals 27, and the Y's are going from 14 to 96, like something like that. Look at the graph again. And then if you want to see what all these points are, right, just hit the trace button, and there's the point 5, 25, 745, right? All the ordered pairs from this table. Right, 525, 745, 1050, right? Just scroll right and left. 1265, 2070, 2586. All right. Let me quit that and just go graph again. So there. Now clearly, the data seem to be, the Y coordinates, these points, they seem to be rising as I move from left to right. So I would definitely say there is a positive linear relationship between these variables, between the percentage of snow days and the percentage of A finals. Right. And then again later we're going to figure out, well, what's a good line I could throw in here that'll best fit these. Again, you're not going to draw a line and hit all the points, but we're going to try to draw a line that gets as close to hitting all these points as possible. All right, and that's called, again, linear regression. All right, so back here, you just have to move all these points around. So this is kind of a bit tedious. And make sure you pay attention to what school is what. So school 1, 5% of the days in January were snow days, and 25% scored A's in the final. So move this to 525, right? Something like this. my goodness. There. And I'm going to come back when I have done this for all 6 schools. All right, again, this is going to be a little bit of a tedious kind of problem. You have to move point school 2 to 745. All right, so like I said, I'll pop this back up when I have completed it. All right, so I've done this, moved all these schools to their respective ordered pairs. And then look, they even, they have this dotted line here. This is the best fitting line for this data, right? This is the line that comes closest to hitting all these points, or with the least amount of error. And again, in a future video, we're going to see how do we find this line ourselves, right? Here they're giving it to us, but later we're going to see how to find that ourselves. What I did to make this a little easier, you saw me struggle with the first point, is I just zoomed in a couple times, and then it made it a little easier to move the points around to the places I wanted. So I'd recommend doing that, just zooming in a little more and making it easier to move the points around. All right, I'll submit this. All the ordered pairs seem to be in the right place. Great. And like I said, these ordered pairs look like they're again, they're pretty close to forming a straight line with a positive slope. So we would say that there's a positive linear relationship between the x and y variables here, between the percentage snow days and the percent of A finals. All right, and I'm pretty certain that this is all for this question. No, there's more to it. All right. So now using the linear relationship graphed above, estimate the percent of A finals if there are 2% snow days. All right, so let's look at this picture. So if there are 2% snow days, so looking at this graph, let me zoom in. This is where we use what we use the line for, to give us a nice estimate. All right, so if I zoom in on this, now I've zoomed in to the point where this looks like every 2, 2, 4, 6, 2, 4, 6. It's actually every 2.5. Back this up a bit. Alright, so 2 would be around here, 2% snow days. If I look up here, we're looking at about, let's see, 2, 4, 6, this is about 2.5 as well. 2, looks like around 25, I'll say 26, right, 26% when x is 2. Now let's see what they say here. 29. It's 2.5, so something close to that. I guess 2.5 would be close. Yeah, it's more near 30, I guess. Well, let me show you on the calculator how I can figure this out more easily. So remember I said this best fit line? Right, this best fit line is given to us here. Let me show you real quickly how you can use the calculator to find it, and we'll do this in another video as well. So let me pull the calculator back up. Now I've already got that scatter plot, right? Now, if I want to find the best fit line, go hit the stat button. And you go over to calc, and you see number 4. See the AX plus B? See, this is reg, that's linear regression. And then what's your X list? L1. What's the Y list, the Y coordinates? L2. There are no frequency lists. And I hit calculate. And you see it comes up with the slope and the Y-intercept. Alright, so the slope is 2.576 blah blah blah. The y-intercept is this b, 22.91. Now I go to the y equals, right? I'll go to y equals and put this up. Now y1 equals, let's go to variables, down to statistics, and then I believe they show up, probably not here, min max, min y, max y, nope. Yeah, here they go. Regression equation. So I move over to this equa, go, after I've calculated, and I go regression equation, and it puts in this crazy formula. Now it's just ax plus b. Let me show you, going all the way back. See the 22.91 for the b, and the 2.57 for the slope, the a. Then hit graph, and look now. See, that's that best fit line. All right. And then they wanted to know, approximately, under that linear relationship, what if there were 2% snow days? So if x were 2, so I can go to a table, right? Go second table, and then you see if x were 2, it's about 28. Now if you put in 28, it might give it to you. It says if x were 2, y would be about 28 on this y1. Remember, y1 here was the regression line. All right. So I mean, that's a way I think you could do it a little better than just eyeballing it. And I'll do this again with the calculator in the next several videos. So if you want, go back and see how I did that again. But you can find that regression line, right? This best fit line, this dotted line. That's what I just found with the calculator. All right. So I'll submit what they put, the 29. Oh, so it looks like they would have taken a lot of values. So my guess earlier might have been okay. See, this is based on the linear relationship that is graphed. When the percent of snow days is 2%, the line has a value between 24 and 34. So it looks like they would have taken anything from 24 to 34. So my goodness. All right, so it looks like they're being a little nice and relaxed here, and you don't need to go to the calculator. But still, the calculator is going to give you a nice, better estimate. All right. Okay. So again, lots of stuff there. Opening instruction on scatter plots. Watching me go over this example, and hopefully watching me go over this, and looking at the more instruction when you need to, reading these answer explanations when they come up. Hopefully all this stuff helps you out when you're working on this material on your own. And thank you very much for watching.